Hi, Karen. A group of us joined at 7:30 today, but then we realized the call changed.
Hi, Mike. Yeah, I was very confused by I'm glad he sent out an email explicitly stating because the automatic calendar deletes ads and, you know, it was very confusing what happened with my Outlook. I think it's Outlook's fault partly, right? I mean, some strange things happen in Outlook.
After you deleted everything, did you have any meeting invite on your Outlook calendar?
No, I did not.
Same here.
And I only got to this because I went to the OCP site and the meeting's listed there, but the invite had not. Yeah. So like I said, I don't know. I think Outlook did something strange. I mean, I say that because separately I'm getting notifications that say, oh, this meeting is now for, not this meeting, but some other meeting is now for 10 a.m. and it's not, and it's actually at noon and it's some strange time zone that Outlook is giving me a readout on. Separately, Jeff, I want to catch up with you, so I'll call you later today.
Okay.
Hi, everyone.
Hi, Bobby.
Oh, so that means I don't have enough volume here. One second. I think my headphone did not pick up. Okay, I think I should be able to hear you guys now.
Nobody's saying anything.
Okay, great. Yes, I can hear you, Karen. That's wonderful. So this is the first time we moved to 8 o'clock. Hopefully we'll be able to attract more peoples, because I know the previous time it looks like not a lot of people able to make it. So hopefully this time will be better. And
Hi, everyone.
Hi.
This is Armagon joining from Nokia. That's my first time joining.
Oh, hi. Welcome to.
Thank you.
Yeah, join the team in here. Which part of the Nokia's that you are based on? Is that in?
I'm based in Toronto, but then I work for the network infrastructure division, mainly focused on hyperscaler data centers solutions.
That's wonderful.
Thank you.
So, is there particular goals that you hope to gaining from this work group?
Yes, mainly I'd like to learn more about the recent developments, advancements in the field, the future outlook, and because Nokia is also looking into the CPO technology and more, so it would be perfect just to get in touch with the other colleagues.
Yeah, great. We have many optical peoples in here, and I think right now we are mainly focusing on getting our white paper complete. We would like to complete a white paper by end of next January. So
great.
Yeah. So that
Yeah,
would
I,
be,
I
that
would
would be
love to
our,
participate and contribute. So,
Yeah.
Yep.
okay. So there's one things there. Um I don't have much to share on my side. I'm kind of swamped by my daily work right now. Anyone want to have anything to share, especially uh, anything news in the OF sites or different site?
You know, Bobby, one thing I might mention is that the Ethernet Alliance has the Ethernet Forum coming up in December. It's about, the path to 400G. Just mention that as something people want to look at attending if they're interested.
Oh, okay, great. So So in the Ethernet Alliance, when they're doing the 400G, do they uh, more focusing on like long distance connections or something
Um, well, I
for
think it's more about the technical challenges and where the industry might be heading. I think the focus here is on AI, and then that involves scale up and scale out connections, and what that means. I that's my understanding of it anyway.
that's great. Okay. Thanks for sharing that. Um, um, I think I missed a couple meetings from your sessions in the OIF. Is there any like new activity or special activities in your EI sessions?
There's no new project starts from the recent meeting.
Got it. Um, uh, so when we working on um, the white paper at 400G part, um, do you know if anyone discussing about what would be the best transition point? Because I think we talked about in the in-person meetings that what would be the different locations that would transition from the electrical to optical, and then since the 400G the electrical cable is pretty challenged to travel for a long time. So that means you, for a reasonable distance, you still have to convert that into convert to optical. That would make sense. And so how? So is there a common everybody's agreements like where would be the best place to transition from the electrical to optical?
Well, my opinion on it, from what I can understand, is people have different points of view. If you're a company, say like Arista, that purchases switches on the regular market, you're going to want to use pluggables, and therefore you'll use 400G from the from the A630s to the front panel pluggable or wherever the pluggable is, and take special care to make that a good channel. And you'll do what you can to reduce energy and consumption instead of going from fully retimed maybe to half retimed or maybe even try a fully linear non-retimed module. There's other people that are looking at, I think, onboard optics to reduce the loss in the channel. And there's also people looking at CPO probably a little further out, as the ultimate low loss channel. And I think it just depends on your business model, what your time frame is, and kind of what your objectives are. That's my current reading of it. I think the optics people are pretty much stuck on PAM4, and the electrical people haven't quite arrived at, whether it's PAM6 or PAM4. But everyone certainly realizes, especially for AI, that there'll be a significant power penalty if you have to gearbox that from PAM4, PAM6 to PAM4, right? So I think in a nutshell, I think that's where it is, and I don't know that there's an answer yet. But maybe someone else on the call has a better update than I do.
Yeah. Thanks, Jeff. Yeah, thanks for sharing that. So another interesting thing said is the how how does industry pushing into this high speed is it going to be widely adapted at the moment, or it's going to moving into a proprietary zone in the near future? Because I think that's also an interesting point, because this is fairly novel and advanced technology, and it would cost a lot to enter this playground. And that's what I think for people who build a data center, and usually they're like the big player, and since they're big enough, so they can probably do something like proprietary. And do you think the market would shift back to the open, or it would kind of falling into the proprietary zone because they think they can move faster by controlling everything?
Are you talking about the electrical side or the optical side?
I think it's kind of both, right? Because if you're thinking about from the system point of view.
Well, I think, again, people here may have a better knowledge than I do, but my view would be on the electrical side, people won't go proprietary so much. I mean, they may add extra features to their SerDes and things, but it takes a lot of money to design and tape out a SerDes, and they'd want to get as broad a market adoption of it as they could. So I think on the electrical side, that would follow the standard. People may do advanced versions of it before the IEEE or OIF is ready with the standard, but I think that's where that would go. On the optical side, I suspect you might find some proprietary things and some, standard things. But that's just my guess. I don't know.
Yeah.
I don't know.
For the first generation of these things, the high level value, robustness, and such is going to be very important. So it is very likely on both ends of the fiber link, things need to be the same. Now, call it proprietary or not, it's very likely that's how it will be successful. Once that gets repeated many times, then people start thinking about interoperability, and that's when standardization or such through open collaboration will come through.
Yeah, no, I agree with that. But you're talking mostly about the line side, between the two transceivers, not the ASIC to the transceiver. Is that correct?
You're correct. I was thinking about the link, but the attachment of the optical engine to the end device, either GPU on this side or memory or storage or something on the other side, even that at least needs to be stated as being something standard, UCIe or something, or be custom.
Yeah, I think Samak, my view in the topic of 400G, those people that would choose 400G as opposed to slow wide, I think that electrical interface would be reasonably standard.
Okay.
And then I think if it's a die-to-die interface, you're right, UCIe, gets a lot of marketing attention. But as you know, the big companies, say it's NVIDIA, AMD, or others, they also have the proprietary, die-to-die interfaces. So that would certainly be less standard. Then there's the, whatever it is between the two transceivers, that link, whether it's electrical or optical or RF, that one I see, there's, potentially more variation, going on in the industry. I think it may take a while for that part, especially in the AI area, to standardize. That's how I don't know if that makes it clear what I was trying to say, but I suspect you agree with that.
I do agree with it, but I want to make sure I understood it correctly. There are three elements that you mentioned. The interface to the big die, that as we said, is a lot of people talk about UCIe as perhaps common, but mostly proprietary at this time. And then that interfaces some other device, some sort of an interface. Is that the one that you said that seems to be stable?
Yeah. So what I'm saying is that.
But this is the piece I didn't understand. If the
Okay.
interface to the big die could be either UCIe or something custom. So what does it mean that the second piece is becoming more stable and people are using the same?
What I'm trying to do is to very simply, and I know there are variations, are simply divided into three sections: the ASIC to a transceiver, then transceiver to transceiver, and then transceiver back to ASIC. And for the transceiver to ASIC and ASIC to transceiver, there are two choices. There's slow wide, like UCIe, or there's high speed, which would be 400G. And I think companies are doing both depending on their business models and what they're trying to do. You'll see a mixture of those two things going on. On the slow wide interfaces, there'll be a lot of variability because big companies, may use UCIe or they may use their own proprietary interfaces. For 400G, serial links between the ASIC and the transceiver, I think that's quite variable. I mean, that's quite standard. People will spend a lot of money to develop the IP, and so that will follow standardization. Then the link between the two transceivers, what I see or seem to see is a lot of variability in what people are doing there. And some of that will be standardized, maybe at IEEE, and maybe some will be proprietary.
Right. So in doing it that way, I mean that seems to be the one that everybody does. But in doing it that way, there are multiple elements from big die on one side and a big die on the other side. There are two elements that they're near package kind of concepts that need to exist for the three cases that you mentioned, and that's the one that adds to a lot of power, and energy per bit goes way high. And that's what everybody's trying to avoid, but it seems that it has to be there right for now.
Yeah, I would put it this way, CMAC, is that if you, one way to think about it is let's say you're going to buy a chip from some company, say a switch chip, and you put that down on your board. If you want to, say, co-package it, that company has to have a business model that allows co-packaging, which means they have to be able to test it before it's packaged. So it's likely that these implementations will have some parts that could be co-packaged, say if you had a custom GPU that you were set up for that. And there may be other parts of the link which would be pluggable or MPO or OBO or something like that, whatever you choose, just because the chip that you buy will already be packaged. And then,
Yeah, I appreciate that model very much. It's very likely that will be the first thing that people do, but at the end, it will end up with having extra energy per bit.
exactly.
But it might be necessary for the industry to get going, and optimization
Yes.
might come afterwards.
Yes, yes.
Yeah, I think that's extremely good point. I just don't know like when will be the ultimate versions will come out. And
I keep, we had this conversation, I don't know, a month ago or so. The parameters people are looking for are reliability, bit error rate type things, cost, of course, performance, of course, but power, energy per bit is very important for people as well, because they keep asking for higher bit rate. Higher bit rate means, well, I need to bring energy per bit down. And we keep, I think the summary of this is we keep saying we can't, because we have to add power to get something, and and that will delay everything.
right. Yeah. I don't know, CMX, do you have any kind of models or anything about the high density rack versus the low density rack in the setup costs or cooling costs or power conversion efficiency costs at some point, because one thing that I have in my mind is the since the 400G the amount of electrical distance is fairly short, so that means it would be hard to jam more computing unit into for example just a rack, right? So it would be hard to link all those things together. It's pretty hard for now already to let the electrical signal go inside a rack, and once you bump the frequency even higher, it would be making even difficult for just fulfilling in a rack. So that would be the time that you're gonna transition to the optics at some point, and once you transition to optics at some point, you jam it into 1 meter is the same as 10 or 30 meter, and so that means you can loosen up how many GPUs that you want to put it into the rack, and that means the single rack power, instead of like 100 kilowatts or 500 kilowatts, you can go back down to something like a 50, 60 more reasonable point, and then using instead of the like liquid coolings, you can go back to traditional air cooling. And that also means the amount of cost to building the rack would be different. And I'm wondering if there is something, a rule of thumb models that we can apply, and kind of saying that there'll be the point, going back to the optics is not just delivering the data, but also lower down the overall data center construction costs.
The rule of thumb kind of thing won't help us here, because if we're not precise about what we want to do, then we have to do them all. Let me try to explain. In your description of the problem, there are a number of parameters to think about. Dimensions of space, how much space I have to pack things at the rack level or at the data center level is one. Is something new installation or brownfield already done? I need to fit things in there. And therefore amount of power and cooling associated with that. These are all where things are. Is it in the middle of the desert somewhere close to a water dam, or is it packed in the middle of a city in a large Japan condensed area, for example? These are all problems. Normally in these cases, if the volume is up, if I can start from fresh, you start optimizing from the beginning, and no parameter is a limiter. Else, you're given a fixed amount of power per rack, for example, power and cooling. In that case, if you have to increase the number of racks to get more power, then distance and those type of things that you talked about come into play and make longer distances a little more difficult. If everything's from the beginning, the amount of power per se is not an issue. You can pack more things, bring more power from adjacent racks or such to the same place. So the amount of power per rack is not fixed. If the amount of power per rack is not fixed, the question is technical things. Do I pack everything together in one package, or do I separate things, disaggregate compute from memory and GPUs from GPUs and such in multiple chassis for ease of installation, maintenance, reliability, and other things? So these are all big parameters, and therefore I don't have a good answer for you.
So Bobby, CMAC, I think that I don't think there exists a clear single answer, and I don't think we should hold the white paper to that. I mean, I suppose at some point the follow-on project needs to define a specific design point. But for the white paper, we could cover a greenfield case and a brownfield case, and exactly as CMAC has just articulated, that's what we could actually say. I do think your point about using optics to reduce the need for liquid cooling is an interesting one. And I think you were asking if OCP has cost figures around the implications of liquid cooling versus air cooling that could be factored into this. That's an interesting idea. I guess I would just suggest that we literally write up what was just articulated and include that.
And before we go too deep, it seems to me that the third case of liquid cooling and optics will be necessary for some of these high-end solutions. So three cases then. Large spaces, freedom of cooling, large spaces, can benefit from freedom of space, which is optics, photonics. Freedom of cooling, therefore liquid cooling, allows us to pack things in smaller places. And that's what a lot of people are trying to do the less costly copper in denser spaces. But then they have to cool it, and immersion or cold plate or such are helping them. They do that to the extent that's feasible. But I also see that a lot of people are pushing even that on that angle. So I want both. So some of us are working on liquid cooled optical things as well. So
job, yeah. These are all fairly good points, and I totally agree with you, Karen. I think we should cover the greenfields and brownfields in both cases, even the like CMX suggested, the third one that is the luxury one for in our session of the 400G. And I think we're running out of time right now. Next week it's a Thanksgiving week, so I already canceled the meetings. I will see you in December. And I'll for the writer, the contributor for the white paper, I'll send out another emails to follow up, to check in on the status. All right. Thank you, everyone. We'll see you next time. Bye.